How many carbs do you really need? Or could you completely live without them and not only survive, but actually thrive and exercise and perform on no carbs or something like a ketogenic diet? Or are carbs an absolute must for our bodies to function?
Can you really live without eating carbs? Hi, I'm Dr. Eric Westman and welcome to my channel where I review and debunk nutritional misinformation online. In this video, we're going to hear from a textbook view of whether you can eat carbs or not. And it's actually a great lesson in considering the source, because you read a textbook and it's necessarily behind the times, unless it's a living, breathing textbook. So it will be interesting to see. The video comes from an educational kind of YouTube channel. And let's see what he says about, can you really live without carbs?
So let's start with, could you live without eating any carbs whatsoever? And to answer this question, it would help to know if there are any cells throughout the body that can only run on carbohydrates for energy. Because if there are, wouldn't that mean we need to be eating carbohydrates? Well, let's find out.
So hold on, this was a flaw that I heard 30 years ago now, that because certain cells need carbohydrates, you have to eat them. No, your body can make them. And actually he gets into that in a good way. But no, just because some of your cells need glucose doesn't mean you have to eat glucose. Glucose can be made in a process called gluconeogenesis, and we'll hear more about that. Hey everyone, I've got something exciting to share. If you love the content on this channel, our YouTube membership is the perfect way to take your experience to the next level. As a member, you'll get early access to new videos, be the first to see fresh tips and insights. Plus, twice a month, I'll be hosting exclusive live Q&A sessions where you can ask me your keto questions and get personalized advice. You'll also get shout outs for recommending videos to the community, just our way of saying thanks for helping spread the word. So, if you want early content, direct access to me, and a more personalized experience, hit that join button below and become a member today. Looking forward to seeing you in our live sessions.
As far as if there are any cells in the body that can only run on carbohydrates, the answer to that is yes. Red blood cells, for example, can only utilize carbohydrates in order to make their ATP. Because the red blood cells don't have a whole bunch of other organelles, they don't have to waste any ATP on any of those other extra structures. Plus, it kind of makes sense, right? The whole job of the red blood cell is to carry oxygen. So we wouldn't want the red blood cell to be stealing from the oxygen that it's carrying to the other tissues. I mean, could you imagine a red blood cell goes through the lung, picks up all this oxygen, and then as it's traveling through the circulation, it's gobbling up all the oxygen it's supposed to be delivering to, say, like a foot muscle? And then it gets there and the foot muscle's like, dude, where's my oxygen? And the red blood cell's like, I ate some. Now,
well, I like the metaphor, and the other way to think of the glucose and fat and the way they're utilized in the cell, glycolysis can be thought of as the glucose furnace or the sugar furnace. Glycolysis can be done without oxygen. That means anaerobic. The fat furnace is the mitochondria. So the fat is pretty much used and turned into ATP in the fat furnace, and it requires oxygen. So this is where we get into the shoulds and shouldn'ts and do's and don'ts, and I don't think that's the way we need to look at it. Is that if I like the example here. So the red blood cell has no mitochondria, it has no fat furnace, which requires oxygen. And it wouldn't make sense because the red blood cell's job is to take oxygen from the lungs to the tissue, take carbon dioxide back. So that the explanation there, I think, is really good as to why it makes sense that the red blood cell itself can't use fat and oxygen, or shouldn't, because it's mostly carrying the oxygen. So the red blood cell is kind of the key player, key cells that are in the blood, actually. And remember, if you're measuring blood glucose, if it's elevated a little bit, that's pre-diabetes. If it's elevated a lot, that's diabetes. An elevation in blood glucose in the blood, remember we're always checking in the blood, is where the red blood cells are. In fact, white blood cells, when they're in a respiratory burst, meaning they're fighting infection, need glucose as well. So you may see that your blood glucose goes up when you have an infection. That's so that your white blood cells that are fighting infection can fight the infection with extra glucose. Turns out white blood cells have nuclei in mitochondria, so he didn't mention them as a glucose requiring cell, but I think this is the number one cell to think about that does require glucose. Now, it doesn't mean you have to eat glucose, right? But it does require glucose.
There are also other cells throughout the body that almost exclusively rely on carbohydrates as their energy source, such as the neurons of the brain. And much of the literature will say that the brain needs about 120 to 140 grams of glucose per day. Now, there is some debate on those exact numbers, some citing lower numbers, but the important point for our discussion is that the brain prefers glucose as its energy source.
Yeah, and this is fascinating because the latest research doesn't really support that. So now we're getting where the source of textbooks and new research, which is being done all the time, being presented at meetings, maybe even put in different types of formats, maybe other textbooks. If someone's eating carbohydrates, yes, the brain uses mainly carbohydrates. And that's another thing to remember. It's contextually dependent on what you mainly use for fuel. So if you mainly don't eat carbohydrates and you're running on fat, the brain shifts to using ketones and can use a lot of ketones. And so that information is not as well described in the literature because it's relatively new and just about everyone eats carbohydrates. So until more science is done and more authors of textbooks allow this kind of information in, that it's not just some crazy people not eating carbohydrates, then the textbooks will show that when someone keto adapts to eating proteins and fats, no carbs, the brain actually does start to use more ketones. And it's not that 100 grams of glucose that is the kind of textbook mentioned because it's talking about people who eat carbohydrates.
Your body has the ability to create its own glucose from other substances. The liver, for example, can convert fats and proteins into glucose through a process called gluconeogenesis. Even the kidneys are capable of gluconeogenesis. And from a survival standpoint, this makes perfect sense. If a human being goes without food for an extended period of time, and therefore no carbohydrates, or if a human gets very small and limited amounts of carbohydrates, such as certain populations of people that historically lived in very cold climates and could only mostly rely on eating meats, the body needed a fail-safe mechanism to create enough carbohydrates for the cells that needed them, like those red blood cells and even the brain to a certain extent. And gluconeogenesis can make about 180 to 220 grams of glucose per day. And this is enough to meet the baseline glucose needs for the body. And so this finally does answer one of our questions. You can technically live without eating any carbohydrates. But is this ideal?
Well, before we get to is this ideal, it's important to establish that, and it was written in the Institute of Medicine report 25 years ago when I first was looking at this type of diet as a researcher. I didn't want to harm anybody, so I had to convince myself that it wasn't going to be violating any basic biological principle to teach people how to eat a diet without carbohydrate. And so he's actually correct that you don't have to eat carbohydrates. Your body can make all of it that it needs. The other thing that happens in the brain, though, is a shift to the ketone use. And over the last several years, I've been in meetings where the brain researchers these days are talking about how actually ketones get sucked into the brain rather than the glucose, which is gradient dependent. And so that I would shade the old way of saying it is that the brain prefers glucose. Under other conditions, actually, the brain may prefer ketones. And then the balance of how much ketones, how much glucose is needed, it's thought that some glucose still is needed for the brain in the cells that connect the neurons, that sort of thing. But let's just say there's a lot more to be learned in this area. If a child has seizures from a problem that has to do with brain energy, sometimes putting the child on a keto diet called the ketogenic diet for epilepsy will actually reverse that seizure disorder overnight. And so Johns Hopkins and other universities have taught in worldwide programs now how to use a keto diet for the treatment of childhood epilepsy, where they specifically teach children to not eat carbohydrates, to get the ketones up so the brain can actually get fuel. And there's a problem with that glucose transporter. It's been worked out. So yeah, the brain can use ketones. In fact, in some cases, it reverses seizures. Can be that important.
Especially if we aren't just talking about survival here, and say someone wants to thrive or even exercise and expend much more energy. Is a low-carb diet sufficient enough? Well, it can be. And this is where we get into ketogenic diets and ketosis. So let's discuss what happens with ketogenic diets and even discuss some potential limitations. When a person drastically reduces their amount of carbohydrate intake, the body will obviously start to create some of its own glucose through gluconeogenesis. But again, that can only produce a limited amount. And since we are talking about more than just simply surviving, the brain may actually need more energy for someone who's constantly engaging their brain through various daily activities. And maybe this person is also wanting to exercise on top of that, which would obviously increase the metabolic requirements of muscles and other tissues, but this would also further increase the metabolic requirements of the brain.
Yeah, so again, that idea of adaptation, shifting. I recall a patient who came to me upset that he was not doing his Sudoku puzzle as fast as he used to. He times it to make sure that his brain is working well. It was a month or two into the program, but after 6 months or longer without eating carbs, his Sudoku time was actually faster than before. So if your brain is working on ketones and glucose, you can actually have better performance. I think the insinuation here was that the brain needs glucose. If you're going to use the brain more, you need more glucose. That's the insinuation here. If you're using your muscles more, you'll need more glucose. When actually shifting to ketones and fatty acids, mainly, the muscles do great. And this is really kind of a little bit out of date, although I understand the caution that someone who isn't teaching and training people about this might have to talk about it.
And so in these situations, because the brain can't efficiently metabolize fatty acids, the body will produce other substances that the brain can utilize for energy. And those are known as ketone bodies. Ketone bodies, ironically enough, are derived from fatty acids. The liver will take fatty acids and convert them into these ketone bodies. And the two main ketone bodies are acetoacetate and beta-hydroxybutyrate.
So I'm going to pause here for a moment. It's a brainstorming technique to just flip everything upside down. Just, without regard to whether it's crazy or not, just flip everything upside down. So let's say that maybe the default state of a human is to not have food all the time and to go in and out of ketosis or be in ketosis for a while. And looking at this chart, so basically when you're fat burning, when you're not consuming a lot of food and a lot of carbs, your body has a way of making ketones, which are a fuel source for the brain, for other kinds of tissues that glucose or fatty acids can't get to. So let's flip everything upside down and think for a moment, maybe ketones are supposed to be there. And it's only when you eat carbs that glucose comes in and takes over and pushes away where the ketones have been used, and changing the muscles from just a lot of fatty acids to now having to have some glucose too. If you raise the blood sugar, insulin comes out and you stuff the blood sugar into the cells, including muscle cells, and now you have glycogen buildup in the muscle cells, which causes insulin resistance. And so all of that goes away when your body is mainly relying on fatty acids and ketone bodies. You're not having a whole lot of glucose. But remember, the study of all of this information occurred during a time when everyone was eating carbohydrates and it was normal. So the normal range is what is described for people who eat carbohydrates. That's why if you're not eating carbohydrates, your blood tests may not always fall within that quote normal range for those who eat carbohydrates.
And in prolonged carbohydrate restriction of about 1 to 2 weeks or more, ketone bodies become the dominant energy source of the brain, contributing to 60 to 70% of the brain's energy needs, with the remainder being supplied by glucose derived from gluconeogenesis and or any small amount of carbohydrates the person is still eating.
So what if that was normal or optimal or default, and when you eat carbs, it shifts things toward the carb burning. So the brain actually a majority of the brain can use ketones. And if that is the state of not eating, where human evolution and cultures, it's bizarre how we have food all the time. And I was in front of crowds of people before the pandemic. I got to ask hundreds of people at once to say, how many of you have gone a day without eating? And there were only a few hands would go up, and 300 people. And so we've gotten so used to just eating a lot. So again, what if it was the other way, and that we really should be fat burners, and when glucose comes in, it can be used, but it really shouldn't be the major source of fuel.
Now, other cells can also utilize ketone bodies to make ATP, such as skeletal muscles, especially those slow twitch and intermediate muscle fibers. But skeletal muscle fibers can also utilize fatty acids and amino acids when necessary. But this does show you how people meet their energy needs when they're utilizing a ketogenic diet.
Also heart muscle, and that's a fascinating story of how a medication that causes ketosis has an ability to reverse or prevent heart failure episodes, and that's how many cardiologists now are learning about ketosis through these SGLT2 inhibitor drugs. So even heart muscle itself loves to run on fatty acids and ketones.
And you can kind of think of ketone bodies as somewhat of a glucose replacement.
Or is glucose a ketone replacement?
And so someone eating a ketogenic diet is obviously not going to be getting that excess sugar, and therefore overall calories typically go down and weight loss follows.
And diabetes reversal and other metabolic conditions too.
But there still are limitations to this ketogenic diet for certain people, specifically for certain athletes or people that participate in certain sports and exercises. One of the first limitations is, if you remember, we mentioned that glucose, when utilized with oxygen in the mitochondria, one glucose molecule could produce over 30 ATP molecules. However, one ketone body can produce just over 20 ATP molecules. So we're getting less ATP with a ketone body than you would with glucose.
Yeah, so I don't buy that logic, because how many molecules are you using at a given time? But you can see now we're getting into the old teaching was you needed to carb load before exercise. Get those glycogen stores up, because you had to run on glucose while you're running. Well, Professor Timothy Noakes in Cape Town, South Africa, wrote the book, The Lore of Running, where he taught everyone to carb load days before a marathon. And in a movie called Serial Killers, he rips out the chapter of his book and says, I was wrong, you should go into prolonged exertion as a fat burner. And so this is a major paradigm shift that still most gymnasiums or personal trainers and people in the athletic world still are kind of stuck in that old idea that you had to be a carb eater and a carb burner. Several elite athletes, like world champions, don't eat many carbohydrates, but they fuel or give themselves some carbohydrate during the race. And so that's above my pay grade, or outside my purview. Most patients who come to me are not exercising at that level. So here I want you to keep the context here. If you're in the clinic and you're one of my patients and you're not running marathons, don't worry about this section, even though there's nuance to it with elite athletes winning races without eating many carbohydrates. And he's not going to get into that, I'm afraid.
So finally, back to the question. How many carbs do you really need? Well, by now, I think you see that it really depends. It depends on your goals, it depends on exercise choices and intensity, but there is some data specifically for exercisers and athletes that gives daily carbohydrate recommendations for those that want to avoid running out of energy for their sport or exercise of choice. And these numbers assume one is not overeating fats and has adequate protein intake. And these numbers would be for those that are not looking to do a ketogenic diet, because when people on a ketogenic diet see these numbers on screen, their external anal sphincters will likely contract a little bit more forcefully. And so again, those on ketogenic diets that find themselves hitting the wall during some of their higher intensity exercise sessions, they could start with what I mentioned earlier by adding a few more carbohydrates incrementally.
Well, so you can live without eating carbohydrates. The cells that need glucose, I would add to the red blood cell and some of the brain cells. There's a part of the kidney where the oxygen tension gets very low. It's part of the reason we can concentrate the urine. And I remember in a comparative anatomy physiology course, it's one of the things that allowed evolutionarily the fish to become mammals and live on the ground, the ability to concentrate the urine. So when you concentrate the urine, the oxygen tension gets very low, almost to the venous level, and that doesn't support the Krebs cycle or the fat burning, the fat furnace. So there's a vulnerable part of the kidney called the renal papilla, kidney papilla, that is a glucose requiring cell part of the body. Now, what's fascinating is the kidney itself can make glucose. So it's not just the liver, it's the kidney can make glucose, the process called gluconeogenesis. My hunch is that we're going to learn that other cells are able to make glucose as well. It just hasn't been well studied. So red blood cells have no mitochondria, no nucleus either. They must have glucose. The kidney cells, some of the brain cells, or I guess some of the kidney cells, the white blood cells with a respiratory burst need glucose. I'm still trying to learn if the eye, the lens, and the cornea, and the retina, not a lot of data. There's no book you can go to that says, here's a list of all the cells in the body and here's the fuel that they use. It's like nobody's been interested in this. I can imagine why. The body has a way of just handling things on its own. So yes, the body can make its own glucose and fructose if it needs it for the biologic processes. I'm reassured by experience in the clinic over the last 25 years and that initial kind of statement that you didn't have to eat carbs from the Institute of Medicine, that you are not going to be harming yourself if you don't eat carbohydrates. Now, whether you like them and want to, that's a different issue. If you like, please like, subscribe, ring the notification bell, and look for new content on Wednesdays and Fridays.